All right, welcome back to Missouri Caves and Speleology. I'm Toby Dogweiler. Today, in this module, we're going to discuss Mammoth Cave in Mammoth Cave National Park and its geology. And later on, we'll be talking a little bit about climate, and understanding Mammoth Cave will also help us understand how caves and karst can help us understand past climates on Earth. As we start today about Mammoth Cave, I want to point out a book. This book's over 35 years old now, but it's still a great resource if you're interested in Mammoth Cave or even just in caves in general. It's a geologic guide to Mammoth Cave National Park by Arthur Palmer. Art Palmer is one of the foremost cave geologists, cave scientists in the world, and he put this book back together in the early 80s. And if you ever visit Mammoth Cave, it's a great guide to help you understand the geology of the area, one of the most significant caves in the world. And if you're just interested in caves in general, it's a very accessible overview of a lot of the topics we've discussed in the class. So I encourage you to get that. As far as I know, it's still in print. So Mammoth Cave, why are we studying that in a class that's focused on Missouri's karst? As we mentioned earlier in the course, we were going to use Missouri and its karst as a focus for the course, but karst is a worldwide phenomenon. It's common everywhere around the planet. And so sometimes we're going to speak about topics that are outside of the boundaries of our great state. Mammoth Cave is the longest cave system in the world. In many ways, it's a very unique cave system. When you put all its pieces and parts together, all the different caves that are connected to Mammoth Cave, it's likely that that system would be over 500 miles long, although officially it's only about 365 miles, because some of the caves that connect to Mammoth outside of the national park boundaries haven't been officially connected. The objective today is to discuss Mammoth Cave, why it's unique, but even more importantly, we want to use Mammoth Cave as an example for understanding the relationship of cave formation to the water table and changes in climate. So in this module, we're going to focus on Mammoth Cave and its relationship to the water table. Just to revisit a map that we looked at earlier in the semester in the karst geography module, this is a map. The red areas are the portions of the United States that have significant karst development. And what you see is, of course, a lot of red over the southern half of the state of Missouri, but to our east, much of Kentucky and Tennessee is also associated with karst geology. And Mammoth Cave, of course, is in west central Kentucky, about an hour, 90 minutes south of Louisville, near Bowling Green. Coming back to another figure we've used throughout the course, this is a generic karst landscape, and we've already talked about the details of this figure, but what I really want to emphasize here is something we really haven't mentioned in the past, is that this figure implies multiple cave levels. We see along the center part of the figure a more or less horizontal passage that's well above the current spring and surface stream that's associated with the landscape, and then a lower passage that sort of curves down from that upper passage and winds back up towards the spring and the surface stream. So we've got multiple levels. Many caves have more than one level. And the question we want to ask today is, why do these levels form? What causes them to exist? Why aren't caves all in one level? Or why do caves have levels at all? So that's where we're going with this. First, we'll take a look at one of the oldest maps of Mammoth Cave. This was put together by Stephen Bishop back in the 1800s. Stephen Bishop was an early tour guide in the cave back in the 1800s. He was also a slave. While he was guiding in the cave, he often was working on surveying and mapping the passage, and he made what turned out to be a remarkably accurate map of the cave that was used for many years as the map that got shown to tourists visiting the cave and so forth. I think that Stephen Bishop's map has mostly been replaced now by much higher resolution and even more accurate maps that have been worked on over the past couple decades, especially by the Cave Research Foundation in Mammoth Cave. But nonetheless, what I'd like to point out with this map is if you look, the passages of Mammoth Cave, all those black squiggly lines, it's rather complicated. There's not just one passage or a couple of passages with side passages. If you were to describe this, you'd probably describe it like a plate of spaghetti. There's just passages going everywhere in every which direction. And so in this bird's eye view or plan view of the map, it can be very difficult to discern anything about the pattern of the cave or its geology. So we'll go a little further with that in a second. But first we need to back up and talk a little bit about the global picture. So over the last couple of million years of Earth history, we've been in a period where we have alternating glacial advances and glacial retreats. And we call the glacial advances glaciations and the glacial retreats interglacials. Right now we're living in an interglacial period. The last glaciation, the Wisconsin glaciation, ended about 10,000 years ago. The Wisconsin glaciation reached its peak, its maximum southward ice extent in North America about 18,000 years ago, and it began over 100,000 years ago. So for much of the last 100,000 years or so, North America was in this glacial period, and we had this great big ice sheet sitting over most of Canada and the northern part of the Midwestern U.S. When you put all that ice, this big ice sheet that's up to 3 miles thick, covering much of northern North America, all that water had to come from somewhere. And where it came from was it was evaporated out of the oceans, precipitated out as snow onto the areas where the glacier formed, and then locked up in that glacial ice for 100,000 years. So we made a big withdrawal from the ocean in terms of water and deposited that water on the land, which means that sea level actually went way down. We took 120 meters or well over 350 feet of water out of the ocean. So at the peak of the Wisconsin glaciation about 18,000 years ago, sea level was 300 feet lower. Now these glacial advances don't just happen steadily forward and then the glacier retreats. It's often 2 steps forward, 1 step back, or 3 steps forward, 1 step back, or 5 steps backwards, 1 step forward. You get my point. But the point is that during these periods when we have these big ice sheets, sea level pretty rapidly rises and falls as the ice sheets expand or contract. So that means sea levels constantly during these periods going up or down. Now, if the ice sheet stabilizes and stays the same size for a while, then sea level stabilizes and stays the same size. Now, the significance of all of this to the cave is that the cave is essentially part of the surface hydrology of the region. So Mammoth Cave or any other cave, it's the pathway that water takes after it falls as rain and gets gathered and concentrated and begins to flow, and it goes underground for a while through the cave system, and the cave is formed to drain that water. But those cave systems are directly linked to surface streams upstream or downstream of the system. So when sea level falls, in North America, that means the mouth of the Mississippi River gets lower because the Mississippi River needs to flow down to sea level. So if sea level goes down, the mouth of the Mississippi goes down. The rest of the Mississippi tries to erode sediment out to deepen its valley to get down closer to sea level so it's not so steep. And then all the tributaries, the Ohio River, which is a tributary of the Mississippi River, it has to lower its stream bed. And then the Green River, which is a tributary of the Ohio River, needs to lower its stream bed. And the Green River is the river that drains the surface water in the Mammoth Cave area, and that Mammoth Cave ultimately is more or less a tributary to the Green River. So whenever these ice sheets expand, sea level falls, the river system has to fall with the sea level. That causes these river systems to cut in. That drives these river systems to lower levels. If the opposite happens and sea level comes up, the rivers have to fill in their valleys and move their beds up. What this means, if we look at the figure, this is a simplified cross-section of Mammoth Cave. The Green River would be there toward the right side of the figure, the deep valley. And you see that the cave system connects the area that's over to the southeast or the left of the figure through various sinkholes and passages, and it transmits that water underground underneath those ridges to the Green River. So right now you see that the Green River is relatively low. It's deep in that valley. And the current active cave passages are those lowest cave passages. Those are the ones that are actively transmitting water and forming. Let's take a look at a cartoon that illustrates the concept of this relationship between different cave levels and sea levels, as driven especially during the ice ages by these changes in global ice sheet volume. So here's a hypothetical water table. We looked at a version of this figure in an earlier discussion. And so I'm repurposing it here. The water table, of course, the boundary shown there, there's an arrow pointing to it. It's the boundary between the gray and the blue. And below the water table, all the bedrock pore spaces are saturated with water. Above that area, the pore spaces are unsaturated. You can see that that water table is directly connected to surface water, which in this case could be a river. So we'd be looking at a cross-section of a river. Well, because if sea level is stable and the river level is stable, then we might form a cave along that water table, because that's the pathway that water is going to take from the uplands in this landscape down to the surface water stream, where it might come out through a spring after it passes through the cave. Well, if sea level drops a little bit and the river level follows that, then we get that older passage is abandoned, and we get a newer, lower passage that forms that helps complete that hydrologic connection across the landscape. Of course, you can do this as many times as you want. Sea level can go up and down quite a bit during these periods. We'll do a third one here. We show that the water tables drop yet again. The river's retreated even more deeply in its valley, and we had to form a new cave system to make that hydrologic connection. So these caves are forming at or near the level of the water table. So anytime we get a water table that remains stable for thousands of years, or long enough anyway to form the cave, we can get a new cave level formed. Now this can also go backwards. We can have the water table rise back up in response to these changes in increasing sea level, and sometimes it'll rise up quite high and we'll fill in passages. We might have a big passage that had formed in an earlier sea level water table relationship, and now the water tables come back up and we've deposited a lot of sediment in that passage, and only the very upper part of that passage is still open. The rest of it's been filled in, and a lot of passages in Mammoth Cave are exactly like this. Some of the big passages on the historic tour that you may see if you ever visit the cave or if you go online and look at pictures, as big as those passages look, in some cases you're only seeing the very top part. There's much more passage than that below your feet that's all filled in with these sediments. So this is another hypothetical, it's not hypothetical, this is actually just a cartoon representation of the 5 to 6 major levels in Mammoth Cave. It depends a little bit on who you read and how you count them, but generally it's accepted there are about 5 major levels in Mammoth Cave, and each of these represents a period of stability in the level of the Green River, and as a result the level of the water table in the area during these changes over the last thousands and tens of thousands of years during these ice ages, in fact over a couple of million years. And you could go into a lot of detail about what was going on and what caused each of these levels to form, but for our purposes I just want you to understand that each of these cave levels, which we could vertically label 1 through 5, represents a past climate scenario which was a combination of ice sheet size or lack thereof and sea level, and the relationship between that ice age and sea level advance. And we'll talk more about this then. That means what this tells us is that caves record information about past climates in them. Even just the fact that they have levels tells us something about past climates. And we'll talk more about what else we can figure out about past climates in the next module. What I want to close this lesson with is another view of a more modern map of Mammoth Cave. These are just stick line maps of the main passages in Mammoth Cave. And in this case, if you look at just all the lines, the blue river that runs across the upper left corner there is the Green River. That's a little strange to say. The blue river running across the map's actually the Green River. But the passages that you see there, that spaghetti, we can start to make some sense of them if we color them in. What we see here is each color is a different cave level on this map. So that's why it looks like spaghetti when we just look at them all, like in Stephen Bishop's map where they're all black and we just map them, is because a plan view map where we have a top-down view, unless you color code the levels, you don't understand that there's a vertical separation between lots of those passages. They're not all just in one plane. And what we're seeing then are different vertical, the vertical positioning through time and changes as the Green River has responded to these external changes in climate. And that's what's driven the Mammoth Cave geology and formation over the era of glaciers and interglacials. So with that, we'll close this module. Thank you for joining us again for Missouri Caves and Speleology.